How's it going, everyone? Welcome, Euler, again. Today we're going to look now at the flow control in promise to understand now how can we trigger this promise in sequence or this time-dependent data as well as in parallel. So let's get into this, right? So we look at particularly exercise here, right? Especially on the
So let's practice. We're going to go back to the same exercise that we did before. I want you to open up exercise 3.
And that is, well, let's going to take a look at those particular two exercises that we're going to do in today's video as a way to understand now this sequence and then ask a couple questions about it.
To give you the hint that kind of like what we did in exercise 2 where getFile produced something, now getFile is going to need to produce a promise. So we're still going to call getFile 3 times, one for file 1, one for file 2, one for file 3. We're going to get 4 promises back. That's the easy part. I'll give you that for free. But now your task is, using what I just taught you about how promises chain together, how are you going to sequence the responses to those promises? In Thunks, the way we sequenced them was to nest them together. But how do we sequence promises together? I just taught you to. Go back and look at.
In this exercise here, just the oh my god. All right, let's get into this exercise. This is the exercise 3, in which we're gonna say, hey, exercise 3. So how do we sequence the promises?
But now your task is, using what I just taught you about how promises chain together, how are you going to sequence the responses to those promises?
Exactly. How do we sequence the response of promises? Okay, pretty straightforward. Actually, the way how you can sequence this is by using is now the dot 10, and this, unlike songs that you're gonna pass a callback and delegate that control and they invert the control. So here it's a hey, no. Promise is a placeholder that is promise is a placeholder of these eventual completions of this future value. So promise is the codification of this idea around that we need to sorry, it's the codification of this idea that we need some sort of placeholder that allows to eliminate time as a concern wrapping around a value, right? So with that, instead of actually thinking of promise or this task that we want to complete at some point in the futures, like passing a callback, which is something that we did in Thunk, promise say, well, what you're gonna do is to subscribe, pretty much like an event listener, subscribe to this function that I'm exposing to you, okay, the dot then, that by the time internally, which is with the promise, and this is the promise here, as you can see here, with the promise here, right? So by the time that now that is fulfilled, all right, internally in this object, I'm going to now trigger is those callbacks that you pass in the dot then, right? So here is now giving you an event handler, giving you an event handler, which is on the dot catch, okay, as a way to now is by the time that this placeholder, this event listener, this callback manager, as you can think of this, of promise, is now getting the value that it needs, or something went wrong, now you're going to actually run this callback that is attached to this event listener. For example, .then or .catch for error handling, right? And the thing is that by now having this promise, the .then, where you can now attach some async action that you want to do after that, if you want to now change more of that, you need to return a promise as well. This is something very, 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 very interesting. It's a way to have this mental model, and especially when we need to handle with this concurrency, these tasks that can happen, these tasks that can overlap at a time. So this is the 3 possible states in which your promise can be: pending, fulfilled, and rejected. Okay. But again, is this placeholder, is this promise that is actually handling is this particular states, right? That it has the pending, and then he's now actually behind the scenes is coordinating, is waiting for that task, for the moment, for how long do we have to wait for this task to be completed, so we don't have to handle that. And that's something great, That's a huge deal, man. That's a big deal, man. That's a big deal that we don't have to worry about the time of this. And that we can now, this is also something beautiful for sequencing animations, because now you can say, hey, I want to make this animation to happen here, and then this another one, this another one, this another one. That's something, okay. Again, because remember that at the end of the day, this is all about to handle this concurrency on applications. These tasks that overlap at a time. The state and fate document from the original promise proposal contains more detail about promise terminology, colloquially resolve, but as illustrated in state and fates. This promise is already resolved at the time when it is created, because outer resolve is called synchronously, and this resolve outer is this one. But it is resolved inner, and therefore won't be fulfilled until 1 second. Exactly. In practice, the resolution is often done behind the scenes and not observable, and only it is fulfillment or rejections are. Promise itself has no first-class protocol for cancellation. And this is something interesting because it's something that this is something interesting because this is something that it will invert the control if you're trying to cancel that, which is one of the problems that Kyle Simpson was describing. That if you try to actually, at some point, someone's there out there is trying to cancel that, well, that is something that you don't want. That perhaps, especially when you need to pass, especially when you want to let, when you want to allow someone, some future state, or something in the future, or something away, can modify the state of your application. So one of the things of this is that by looking at more interesting approach, exactly. For faster execution, all synchronous actions should preferably done within one handler. Otherwise, it will be take several ticks to execute all handlers in sequence. JavaScript maintains a job queue. Each time JavaScript picks a job from the queue and execute it to completion. The jobs are defined by the executor of the promise constructor. The handler passing to the .then on any platform API that returns a promise. The promise in the change represents the dependency relationship between this job. When a promise settles, the respective handler associated with it are added to the back of the job queue. A promise can participate in more than one change from the following code. That's right. But this is as a way to how you can now change that. Which this is not the least important things of changing that. And you will see that there are actually much more better way to do this. Right? Exactly, because at the end of the day, these are now a object. These are now is, as long as you have now that's the same signature, you're gonna have that. Promising concurrency. The promise class offer 4 static methods to facilitate asynchronous task concurrency. So you whether is promise.all, so fulfill when all promise are fulfilled, and reject when any of the promise are rejected. Promise all settle, fulfill when all promise settle, and there is a difference between fulfill and settle. All right. Because based on this terminology, and it is important to understand the difference here, settle, a promise says to be settled if it is either fulfill or reject, but not pending. You know, this is a subtle definition here with this. So promise.all fulfills when all promise are fulfilled, rejects when any of the promise reject. Right? So if you take a look now at this 4 ways of how, of 4 static methods to facilitate asynchronous task. That's right. So you have promise.all, where it's going to be when fulfills when all the promise fulfills, or reject when any of the promise reject. Right? If you have all of these chains of promise, right? And if any one of them change, and if one of them fail, all of them fail. So because this is now the way how we can propagate all of that. So this is promise.all, and the other is promise.all settle. Again, all of this inner mechanism, this placeholder that is happening here, okay, is being handled that for you, which is a great thing, because now the coordination problems that we have when we need to write as our applications, especially asynchronous application, where we need to communicate to several of these external services, web APIs, you name it, right? And we need to actually is do that in an asynchronous way. which means that, hey, or in this time-dependent manner, which is, hey, once you get that data from the server A, now the response we're gonna be use that as we're gonna be use that as the promise of the next. We're gonna use that to call around this promise, this concatenate future event, or this concatenate Ajax request to server B, and once that is and when we get a response from that, now we're going to use that to run the promise 3, which is communicating to, which is making the Ajax request to the server C, and so on and so forth. And this is something interesting and powerful, especially for transactions, which is one of the things when they talk about here in Saga, right? And this is, again, this is not the next level of competency for JavaScript developers, that we need to be tactical and strategic when it comes to write this, when we need to handle the concurrency in an application for async programming, okay? That's something huge. And we need to have the discipline to learn and understand the terminology and this subtle nuance in there. Okay, makes a lot of sense. So the promise.all, promise.all settled, promise.any, and promise.raise is say, hey, the coordination problem that you don't have to worry about it by actually is calling is this sequence of promise or sequence of Ajax requests that we looked at in previous videos, how actually we have to manage that, for example, using callbacks, by having is a global object that is going to keep track is all of this particularly response and store that into this global object to actually match that. And then waiting for them to come back, coordinating all of this response as they came in, and response as they come in, or as they came in. So we can then now is show them in the proper order as they were called. So we don't have to worry about that. There is a particular thing interesting that we made here in this exercise, right? We don't have to worry about that by creating this response and then handle is this here, all right? By saying is, hey, you know what? Exactly. Hey, you know what? It'll be great to actually handle all of these different. This is the way of how we are now handling is all of this incoming response, append that into this record, into this map, and by the time we get all of them, we're going to show them in the proper order, which is a fixed order that we have here using an array. So, and this is and this is just to describe is one particularly fixed example, all right? Because now, in the case of thunk, which is we don't need to actually handle the coordination because we are using is now a closure for that, and thunk is now a closure state around a value, or in other words, is this time independent container of a value, which is a great thing. But the problem is that even though that improves the readability of this, which is something that the way of how we can actually now call them in sequence, as you can see here, request all files at once in parallel. The idea here is that they are not in parallel. In fact, they are in sequence. But as we can see here, when we use now thunks, So thongs now solve that particular issue that we have, for example, with callbacks, by saying is that, hey, these coordination problems are going to handle that using the closure for you, so you can now is write these things as it is. When we have to handle is now the synchronicity using callbacks, it's actually not that it's quite messy. All right, in terms of that we have to now keep track of this way of how we handle that, how we manage that. But in any case, this is it, right? This particularly problems of now that we can handle is this, that we can now have these placeholders that'll be responsible for handling all of these coordinations, okay? And then we're gonna get is our time, depending on the way how you wanna solve. We're gonna get a wrapper around a value here. So we eliminate time as a concerning factor, which is a huge deal. And instead of passing a callback, which is now we invert control, we say, hey, let's gonna have now these placeholders, and it's going to subscribe to events. So by the time that promise is resolved, that future value is resolved, we're gonna get that inside of this particular callback that we pass to this event listener. So promise, after all, is now this event listeners. You can think also as promise as a callback manager, and it makes a lot of sense. However, it also comes with some, because this is not perfect, and since this was a thing that originally language like E, a programming language made by one of the TC39 commit called Mark Miller, actually make that language. And then we have something close to these things that they call in E features. We have something close to that. And if you can think this, this particularly promise, which is after all is one of the things that we want or we care as a programmers, is that, hey, we're gonna get this value and I want to compose that with other future values, these compositions. And this composition concept actually comes from the functional, because that's what promise at the end of the day is a monad. So things is starting to make sense with monads here, slowly but progressive. Because what is a monad? Okay, a monad, in simple terms, a monad is a structure that combines program fragments, functions, and wrap then return value in a type with additional computation. In addition to define wrapping monadic type, monads define two operations. One to wrap a value in the monad type, and another to compose together functions that output value of the monad type. These are known as monadic functions. General purpose language use monad to reduce boilerplate code needed for common operations, such as dealing with undefined values, failing functions, or encapsulate bookkeeping code. Bookkeeping code, exactly. Functional language use monads to turn complicated sequence of function into succinct pipelines that extract away control flow and side effects. This is something interesting, because that's exactly what it's doing. This monad is abstraction control flow from us. We don't have to worry about these coordination problems or these things that can happen. So once I get the things, now I have to handle is all of these two things, and then those two things I need to combine that with the third one. By the time I get that, now I want to combine all of this data. So you don't have to worry about this. Monads make semantic explicit for a kind of computation. They can also be used to implement convenient language feature. Some languages such as Haskell offer pre-built definition in their core libraries. All right. So if we take a look now at the monad for category in mathematics, okay, the power set monad it is data that you can apply to it is data that you can store, and then you have some sort of defined rules of how you can now get some data and get some data from this, and also some sort of defined rules to actually change the state of that, which is interesting. That's one of the reasons why it's abstract away control flow and side effect. Perplexity. Show an example of monad in JavaScript. Explain to me like M5. Example of a monad in JavaScript, because it's an object exactly that can now iterate through this and have a specific way of that. So it is safe to assume that Redux API is a monad. I think it is. It is not entirely accurate to say that Redux itself is a monad, but it does share some characteristic with monads, particularly how it manages states and actions. This is quite interesting. Because now here with just function, it say, hey, I'm gonna expose this particular function that you can do, this particular rule that you can apply to this data, whether it is to get the data, whether it is to change the value of this data, or to change that. Monad help us keep our toys organized and make sure we always know what's happening then without making a mess. It gives you this particular order and sort of this. Holy moly. Let's get into now the exercise here, shall we? Let's get in now here to the exercise here. Let me actually create now a new one. Okay. Holy moly. So, alright. So in this case, instead of doing this, we're gonna say, hey, let's go to return a promise. And we have to use this the new keyword promise because it's a function constructor that initial the first value that it received is a function, right? Function is a function constructor here, okay? It's a function constructor that will say, hey, this will be is our executor, right? This function will be our executor that will receive as a result and reject. And here by the time now we say, hey, set timeout here, okay, I want you to now is run is the resolve, okay, after 1000 seconds. Pretty much it. However, you may wonder, it's like, yeah, you want to run the resolve, but the resolve is also a function that is say, hey, what am I going to resolve? You know what I mean? So what you can do here is to say, hey, well, because now I want to fake my Ajax. This is when I want to actually do the Ajax, fake Ajax here. And this fake Ajax required is the URL, which is the file, okay? And what am I gonna pass to this? I'm gonna pass now is the resolve to this. Why is this? Because now by the time that this placeholder, event listener, that we can think of the promise, is being done, all right? We're gonna pass this the reference to the callback, okay? That'll be now is run the function that we need to. In this case, is this one. You know, after f amount of time, it will call now this with this particular value. Again, this is because now the way of how we are actually defining this particular code base. But here we're just passing is this reference. He was saying, hey, pass this reference, which represent is that this is done, that this is resolved, and then now trigger is this one. Trigger is a callback with that function, right? Trigger is a callback with that function. And once that is done, you're gonna return now a promise here. So as a way to actually is for us be able to access to this, we say, hey, we can just create all of this instead of thongs, we say promise 1, promise 2, and promise 3. We can say, hey, let's go to first get the promise 1, all right? Well, by the time we make this first call, we're gonna get our first response, okay? And this first response, which will be the promise. So by the time we now is subscribe to this, okay? So by the time that this is resolved, okay, we want us to actually is say something like this, output. We put output here because the signature actually match, the function signature match to what we're gonna get initially, right? Because here the signature that we get from our then, as you can see, is the first parameter is the unfulfilled value and the second is unrejected, right? That's what we can now make the things to happen. Similar for after that, you're gonna say, okay, so now let me now change is the promise that I want to do. Unfortunately for us, we can right now change is this. In other words, we can change, we can just simple pass sp2 because this won't work. That's a shame. We need to actually return the promise here, which is we need to say, hey, return is p2, right? And then you say, hey, the then output here, right? You can see you're starting to realize what is the pattern here. Like this. Similar for this. So what you're doing is that, well, so after you get that, all of this is just like subscribing in this propagation sequence that you're getting here. This is quite interesting with the dot then, because it's like propagating, it's like you are subscribing to this change of things that happen in sequence for you. So you can now write code in a sequence manner. Say, hey, after that I want to now run P3, okay, want to return that promise, and then not only subscribe again to this with the output, okay, but also, since we're already done, I want to say, hey, I want to now is here say something like console log, or say is output complete, right? So complete. So if we run this in the console, right? Now this will work as expected. You see? We're going to see complete here. We're requesting these 3 files, and we actually show them in the proper order. You know, first actually far quickly, it took some time to actually show the middle, and then the last, and then the complete. This is something huge because this improves readability vastly, bro. Vastly, bro. So now let me put here is this or concurrency with promise. Handling concurrency with promise. That's beautiful, bro. Oh my God. That's beautiful. That's beautiful.
In thunks, the way we sequenced them was to nest them together, but what if... So let's talk about this exercise from the perspective of promises, a new tool that we're learning to try to help improve the way we solve the problem. Make the fake Ajax function. One is at some point going to finish. We're assuming this, do it like that, but it turns out even easier when I have one. That doesn't mean you won't ever use a function in ways. Just for completeness sake, with the other, no matter what it does, if it calls that resolve 50,000, and I wish that's how promises worked. I wish you could pass a promise in to the then method and have it automatically know what to do. Unfortunately, promises don't have that feature, so you have to pass in a function that returns that promise. Again, an example where people use arrow functions all the time. Is this a case where I'd make that into a function declaration? Perhaps. But for our purposes, just to keep things clean, I'm going to use the function expressions with the admonition. You want to try to minimize the amount of expressions in your flow control. And if you're going to have them, by goodness, please make them like one-liners. If you have 5, 10, 15, 100 line inline expressions inside of your chains, that's a terrible idea.
So that's one of the reasons why people actually use a lot of is arrow functions here, to actually simplify this into actually make it much more readable here. Because promise doesn't work that way. That's why we have a bunch of this. But now look at this. It's like this actually is simplify a lot of our changeables things. It actually now make it much more predictable. Is sequential blocking of how we reason about our code. Damn, son. Jesus.
Example where people use arrow functions all the time. Is this a case where I'd make that into a function declaration? Perhaps. But for our purposes, just to keep things clean, I'm going to use the function expressions with the admonition. You want to try to minimize the amount of expressions in your flow control. And if you're going to have them, by goodness, please make them like one-liners. If you have 5, 10, 15, 100 line inline expressions inside of your chains, that's a terrible idea. Okay? If you have 5, 10, 15, 100 line inline expressions inside of your chain.
Exactly. Mm-hmm. 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 The idea is to keep your lines of code. The idea is to keep your promises or your chains of promises readable as much as possible. The idea is to keep your chains of promise readable as much as possible by making making inline code. Exactly, by making inline code run, by making inline code small as possible. For example, here. Mm-hmm. Mm-hmm. Well, again, not you can always get that, you know. You can always get that. These last lines are the one that matters.
That's a terrible idea. Okay? Return P2 from the chain, which means that the very next step that happens here is going to magically be return P3. The readability factor by a bit. But that's the least important part of what's happened. We've also introduced all of the sanity and trust that comes from the promise mechanism. We can trust that if that fake Ajax utility somehow misbehaves or is malicious or is hijacked or whatever, we know that it can, no matter what it does, if it calls that resolve 50,000 times, we're only going to get notified once because that's the way the promise system is built. So we've shifted our trust from some untrustable third party into a very trustable system, in fact, one that's built into the language. But even if it wasn't, we know we can audit and trust the promise system to do what it's supposed to do. Questions about exercise 3? Yes? Is that what you're saying? But that's not as promise chain oriented. I would prefer to keep the output and the chaining.
Mm-hmm. This is some of the tips here. It's like, exactly. But most of the time we actually don't use this. Keep your logic inside of your then simple.
In separate places, separate steps to reason about. This will functionally work, but this isn't the style I would personally prefer. I prefer a style where the steps are more explicitly separate. You want to think about, this is just general programming practice. Function should be as single purpose as possible.
Mm-hmm. Keep your logic inside of your the then simple to reason about. Mm-hmm. And then this, and then this, and then this, exactly. So keep your logic inside your the then simple to reason about it. Mm-hmm.
So don't make a function that does two entirely different things. Outputting the response from a previous one and sequencing in yet another thing. Those two tasks are separate concerns, and they belong, in my opinion, as separate steps in the chain. Program, if I had another output would get called with that value, created and returned by that method.
So what would the input to that function be? It would be...
Because we don't return anything from output. If I returned something like, hello there, that value that I'm returning from that promise would automatically get piped in and come in here as an argument. But since I'm not returning anything from output, nothing goes.
So it's undefined.
It's the same. All JavaScript functions that don't have a return are the same thing as return undefined. I need to know a line number that somebody's asking about.
Like on 36.
Line 36. What is the value of what? The value of the output function or the value of the .then function?
Where is the resolve defined?
Resolve is defined here. It's passed into our promise.
The previous example?
Order will be, if you have two different thens on the same promise, which is what we have here. Keep in mind, line 39 is not a .then on P1 anymore. It's on a different promise entirely. But line 38 and line 35 are thens on the same promise. In those cases, they go in first registered, first executed order.
And then those they will register in the first execution order when they happen in this first execution order.
You really should not pay any attention to that sort of detail, though. You really, really, really absolutely should not reason about what order something was registered on the promise in. Not that it's not reliable, it is. That's guaranteed by the spec. That's just terrible programming practice. That's way back to those pre-functional programming concepts that we're talking about, where you can't understand the state of your system because you don't see it all at once. Reason about what order something was registered on the promise. You really, really, really absolutely should not reason about first registered, first executed order. It's on a different promise entirely.
First register, first
Line 38 and line 35
execution
are
order.
thens on the same promise. In those cases, they go in first registered, first executed order.
First register, first execution order. If you have multiple promises chaining, if you have the same promise instance chaining, if you have the same promise instance chaining, if you have the same promise instance calling several times, it will trigger the first in the execution order. I'm gonna see if this is actually true, bro. For example, if you say, hey, P1 is the then output. We're not passing any output here. If I clear this, it is executing in that order. It's like, hey, I'm executing this one and then all of this one. It is executing in that order. It will trigger. It will trigger in the first. It will trigger in the first. It will trigger in the first execution order. Okay.
You really should not. Terrible programming practice. It's the idea that we're dealing with and the way the questions are being asked. I think what's
But we're passing.
does that make it easier to understand?
And resolve is not output.
No, resolve comes from the promise constructor. This is built into JavaScript.
Yep.
It produces into the reject. They automatically have an implied reject handler that just simply propagates it to the next step. So that rejection would propagate all the way down the chain. Since we never listen for the rejection, it would sort of just sit there waiting to be observed. It's not really been swallowed, it's there, but we're not passing in a rejection handler to listen for it.
Is that then a new rejection as it propagates through the thens? Yes. So each one will get a new one.
Yes, the default rejection handler, because we're not passing in any rejection handlers, the default rejection handler receives the rejection from the previous step and re-rejects.
With the same parameter.
Same value.
Same value.
Yep.
Okay.
Describing this with a term, right? So the promise is a function that has a value.
This is interesting because now when you take a look at this,
I think so.
Okay. Capital P promise is built into JavaScript. It is a constructor for fulfill.
You send it.
Switch hats to think about how you respond to a promise resolution. Some of the questions are kind of conflating when people are saying, is this the resolve value or whatever? That might be where some of the confusion is trying to
Avoid, so that's why I'm asking.
Yeah,
Continue to try to understand.
I absolutely, that is the antithesis of everything I teach. I do not want the message to be, don't understand it. I want the message to be, understand it separately. So here, when I call, it's got an internal array of them been registered, and one of those promises.
Are you going to get to like catching errors?
Message. Anywhere, the promise that was returned, passed and you register error handlers, you can put an error handler there. If, on the other hand, your assumption is that an error in you have to discover as you play more with, just to make sure we're
Like, and that was where the result.
that there is such a thing as called p2 dot then complete. Promise help. If you find
your error handler, your error handler will be managed based on your needs per level or at the end. For example, you can say is dot catch if something went wrong. Right, but this is now interesting. This is a very interesting thing of how you can handle, because the whole point of this is to make it readable as much as possible. As much as possible. That's what you need to pay for your mentors, bro. That's what you need to pay for your mentors. Error handling per level. So the per asynchronous operation per AJAX calls. This is now per at the end. However, one of the way of how we can handle this is, but for example, if we say promise.all. Hey, if all of these promises were fulfilled, get it there. If not, okay, if all the promises were settled, which was whether it's fulfilled or rejected, okay, which is now promise.all settled, actually allows us actually provide us is an object where we can look at what went wrong. Okay, which promise actually went wrong? Mm-hmm. And reject when all promises rejected. And promise.raise says settle when any of the promise settles. In other words, fulfill when any of the promise fulfill. Reject when any of the other promise reject. Mm-hmm. Note that JavaScript is a single thread by nature, so in a given instance, only one task will be executing, although control can shift between different promises, making execution of the promise appear concurrent, parallel execution. In JavaScript, it can only be achieved through worker threads. Exactly. So, that'll be all for this video. Take care. Bye-bye.